So next on the docket is going through some of the exponent laws. Now there's about 7 exponent laws or so, depending on how you wish to word some of them. We're not going through all of them in this course. We're only going to be covering about 4 of them, just so you have an idea of what's going on. We need a couple of these. We need the first one in order to multiply polynomials, which we will be doing next. Then we're learning one so that we can apply it to a couple others. And we're learning those so that we can understand how to write numbers in scientific notation. But we're going to go through all of the exponent laws right now, and then use just a couple of them in the next segment and the others in the segment after. Okay. So, exponent laws. Well, we have laws everywhere in math land. And the exponent law here says if we are multiplying like base numbers, so b for base, and we have some exponents, so it's b to the m times b to the n, where m and n are whatever numbers you like, we can simplify that and write it as a single factor. So in multiplying like base numbers, what we do in that case is add the exponents. So the result of that is going to be b to the m plus n. Now, how does that work? Well, let's think of a couple examples that would match up with that. If I had x cubed times x squared, we know that x cubed really means, if we were to do this the long way, x cubed expanded really means x times x times x. And x squared means x times x. So how many x's are being multiplied together? 1, 2, 3, 4, 5, Well, instead of having to write it out like that every time, we notice that 3 plus 2 is 5. So after doing a boatload of these, instead of expanding it out like this, we can apply the law that when multiplying like base numbers, you add the exponents. And just to make sure that we're on the right page, what happens if that was 2 to the third times 2 squared? What's our result in that case? Same law applies. That is not a 2 times 2. Only 2 to the first times 2 to the first gives us the answer of 4. This is not 2 to the first times 2 to the first. It's 2 to the third times 2 squared. So you do not multiply the base numbers. Notice in the problem here, it's b to the m times b to the n, and the base stays b. It did not change to anything else. So the same thing goes here. We are multiplying like base numbers. Big number is the base number, that's the 2, so the base number does not change. We simply add the exponents 3 plus 2 to get 5. And in this case, you would then expand that out to find that 2 to the 5th is 32. So that's the one law that says when multiplying like base numbers, you add the exponents. Well, if we have a law with multiplication, you know darn well that we have the same law or a similar law with division. So if I had b to the m and I was dividing it by b to the nth, or it was written in a fractional notation, we have a law for that as well. Well, let's think about it. If the multiplication turned into addition of exponents, division is going to turn into subtraction of exponents. This is b to the m minus n. Alright, well that seems to kind of make sense, but let's make sure that we thoroughly understand that by expanding one out. What if I had x to the 4th over x squared? I now expand it out so that we see the long way, so that we see how the law applies. X to the 4th, once again, would be x times x times x times x. All over x squared is x times x. And now you can reduce. Remember, we can reduce fractions if and only if things are being multiplied. They are factors. And since everything became a multiplication on top, we can cancel anything on top that matches with anything on the bottom. So x on top and an x on the bottom, bing! Remember, anything divided by itself is 1. X on top and the x on the bottom, bing! 1 times 1 is 1. Times x, we're left with just x times x, which we call that x squared. How could I have gotten x squared from x to the fourth and an x squared? Subtract the exponents. 4 minus 2 is 2. Oh, that's kind of a fun one. I like that one a lot. Let's do that one again. Let me do another one. What if we had x cubed over x cubed? Whoop, gotta move my paper up. X cubed over x cubed. Well, okay. I'm a smarty pants now, so I can use the law that says, aha, when dividing like bases, when the base numbers are both x, I can subtract the exponents. So I would get x to the 3 minus 3, which is x to the 0. Well, what the heck is x to the 0? I'm stuck. Nope, I can do something else. Okay, forget the law. Forget the law. Let's do it the long way like we did up here. Okay, x to the third is x times x times x. And x to the third is x times x times x. Okay, and then we get to cancel. Ooh, that's the fun part. Anything over itself cancels to a 1, so we go bing, bing. Okay, everything canceled out, and I'm left with 1 times 1 times 1, which is 1. Wait a second. If the law works and the long way works, which they're both legitimate legal ways to do math in math land, I got two answers that look different. I got 1 over here and I got x to the 0 over there. What can I say about that? I don't know. Think. Well, x to the 0, isn't that just x? No. X. She just said before that every number has an exponent on it. So if it's not up there, it's a 1. So x is just x to the first. That's not the same thing as x to the 0. X to the 0, that must be 0. That doesn't seem to make sense because exponents is repeated multiplication. If I start with a 0, how do I go anywhere with repeated multiplication? 0 times anything is 0 and I go nowhere. I'm treading water. I'm like Wile E. Coyote trying to go after the Roadrunner, just spinning my wheels. Okay, think. I did it the long way and I came up with the answer of 1. I did it using the law and I came up with x to the 0. Both of them are legal ways, which means that the answers have to be the same. I have to get the same answer either way. Same answer. Oh, that means that x to the 0 has to be the same as 1. So my conclusion is going to be that anything raised to the 0 power is the number 1. Ding, 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 ding. Whoop, whoop. $1 million winner. Yay! We need to generate the repeated multiplication. In order to find out what 2 to the 5th is, we would have to start with the number 1 and go 1 times 2 is 2, and 2 times 2 is 4, and 4 times 2 is 8, and 8 times 2 is 16, and 16 times 2 is 32. To generate multiplication, the identity of multiplication is 1, because 1 times anything is anything and it starts us off. So if we have a 0 exponent, the entire entity, not the exponent, but the entire entity of b and the power changes to the number 1. Wow, that's fantastic! Alright, so if I had negative 732 raised to the 0 power, because the 0 power is on the outside of my parentheses, everything in the inside is being raised to this 0 power. That means that this whole thing becomes 1. Cool. Rock on. All right. So that wasn't so bad. That wasn't so bad indeed. Now speak for yourself. I did. All right. So that was when the top and the bottom had the same. Let's do one more of these because this is kind of exciting. All the new things that we can learn. So what if I had x squared over x to the 5th? Okay, using my wonderful law that I learned, I thought the law and the law won. It would say to subtract the exponents. So I would say, okay, that's x to the 2 minus 5. So that's going to be x to the negative 3. So I would take x times itself so that there are negative 3 of them. How do I take x times itself so that there are negative 3? All these darn problems. Okay, let's do it the other way instead. X squared is x times x, and x to the 5th is 1, 2, 3, 4, 5. And then we can have fun with canceling. Bing! Bing! Oh, I ran out of things to cancel. And I have x's left over, but they're down here. On top, I have a 1, and on the bottom, x times x times x would be x cubed. So I used the law, and I came up with x to the negative 3. I did the long way, which is still legal, and I come up with 1 over x to the 3rd. Same type of thought process from the last problem. We did the problem 2 different mathematically legal ways, which means that our results would have to be the same. If they look different, they still mean the same thing. So x to the negative 3 is the same thing as 1 over x to a positive 3. So when I have a base with a negative exponent, it means the same thing as 1 over that base to a positive exponent. So instead of multiplying repeatedly, numbers in the bottom are being divided. So it's going to be divided repeatedly. To change the sign, you gotta cross the line. To change the sign of the exponent, you cross the line. So a negative exponent really means that you're dividing, and when you divide, the numbers get smaller. Now I'm going to let you ponder that one for a little bit. We're going to use that idea of negative exponents in scientific notation. We're not going to make them positive, but we need to realize that a negative exponent means that we're dividing, which means that that number is going to get smaller and smaller and smaller. But before we have fun with that, let's take a little break and go do some multiplying.